So today we have come out to beautiful rural Kazakhstan here to cover a small cobbled together off-grid relay site, internet relay site, which was literally made out of spare parts just to, you know, make it work. So here she is anyway. So here's our panels there and our guide 50-foot pop-up, which is probably only about 40 feet. But anyway, so here, this is the way she works. And then we'll get down to the nitty-gritty of things. So this little dish right here is shooting way off yonder. I don't know if you can actually see it. Let me see if I can zoom in with it. Zooming in at extreme rate. There should be a tower over there. Yeah, you can just see it. Right there on the horizon, there's a little tower. That's where this bad boy's shooting to. There we go. We got ourselves a PowerBeam M5 400 by Ubiquiti. This is our cow-safe enclosure with our lean-to for the solar panels and whatnot. As you can see, the cows have a hell of a time scratching their asses on here. They just love it. There's some shit for you. Alright. This is pretty much a little maintenance trip. We're just going out here to check everything and make sure she's still working good. Let's see what we got here for a gate. This is new to me. Yeah, this works. I like this. Alright, so here we've got our solar panels. We have 4 of them. I think these guys are 130s, but don't quote me on that. I'll do a zoom in and we'll figure it out. They're pretty old used Siemens panels. Okay. Now, see here, we got our turnbuckles over here. The guy wires have already been retensioned for the year. You pretty much have to go back every year and retension them. So this is T-bar. That T-bar is 8-foot T-bar and it's driven into the ground about, well, as deep as she'll go. Alright, over here we have our grounding system. It's another 8-foot rod driven in as deep as it'll go in this gravel quarry. There's our batteries there. Well, let's see how big our solar panels are. Alright. So there's our specs. So they're 75 watts a piece. So we got 150, about 300 watts total here. These are just older panels again. Just some number 12 going between them. Here's our battery pack right here. There's of course the fuse. I always stress this. Your fuse between your 2 batteries, because this is a 24-volt system. We got our ground going to the chassis of the solar panels, which are all screwed together. Going down to our ground rod. Here's another important little part here, which is actually just falling off next to me, is the thermal probe for the batteries. I'm going to make sure that's in there. So that ensures that the MPPT charge controller knows what condition the batteries are in. Now, let's go inside. Here's our box here. There we go. Here's our pad for the friggin' pop-up there, and our guy wires and whatnot. It's a 5 gig feeding to a 900, and 900 feeds all the sub-clients on here. Alright, we're going to pause for a second while I open this thing up. Okay, so now there are a few ways to do this, folks. This is what we did. This is very, very basic, but there's still some critical stuff in here, okay? Look closely. That is a 24-volt MPPT charge controller, okay? That little guy there, its purpose is to get the highest amount of output power out of these solar panels as it can. That's our main battery disconnect right there. So that breaker right there is, oh, I can't see the amperage. I can't remember. I think it's only about 20 amps. But that's to disconnect everything from the battery bank. So we've got a fuse in between the 2 batteries, and we've got a air packs breaker right here, just to break the circuit to the batteries or turn it off when you're servicing it. We've got a cluster fly there, shoe. Those are the breakers for each radio. Each one's rated at, I believe, 1 amp, and they also power the router. So whole 24-volt system here. There are lightning arresters right there. They're just keeping shit from getting blown up. Simple enough, right? Alright, so if you look in here now, this is where we cheated. You can use a Hex PoE to power all your equipment, like basically a Mikrotik PoE router. But instead, we went with Mikrotik power injectors. These are gigabit capable. And it allows us to actually just tie in one of these tails here. As you can see, there's your tail. It allows us just to tie those tails in line with each individual breaker, allowing us to break each of the radios. Now, the reason why we went this way is actually because this shit gets hit by lightning every now and again. This site has actually survived 2 summers now with no issues, but if something gets taken out or it shorts, it'll pop one breaker instead of taking everything down, which will allow me to know remotely that something went offline here. And here we go. We've just got a basic Mikrotik Hex Poe. These little clippies, they need to make better 2/8 tape for them. I try to make this look as pretty as possible, but you know how she goes in the country, right? This is supposed to be a site you don't have to come to very often. Alright, so that is the enclosure. That is the gist of it. Lightning arresters. Breakers for each of the radios in the router. Router. As you can see, she's marching away there. PoE injectors. Main breaker, battery disconnect. And MPPT solar charge controller. Let's see if I can get some LED action there. Can you see the LED? No. There we go. She's idle right now. Yeah, later on I'll show you guys the voltages and stuff, and I'll take you through how to monitor the power on the site remotely. But another little trick here as well is, not only is it handy to have some spare cable at the bottom of the tower, but that spare cable can also work as an induction loop. Everything here is grounded, but in the addition of this, if you get a lightning strike, it'll induce through the coils, out through the ground coil that's on that and down to earth. So you got your lightning protection there, and you've got your lightning protection on that coil there. So, yeah, that's the off-grid site here. Batteries. Now, last couple of things to show you. It's just a basic lean-to. I mean, we're in southern Ontario here, and it's not like it has to look pretty. It has to be extremely functional, though, and it's got to be able to take some of the worst weather Mother Nature can throw at it. That's pretty much what she wrote. And now, for one beautiful panoramic view of rural Ontario, Canada. Isn't that just beautiful? Alright, so yeah, that is the solar site. Now, I'm going to obviously jump cut this, and we'll go back and we'll do some calculations to show you how to figure out how much power you need for one of these sites and to keep it running for a while. Those are two, I believe they're 110 amp hour RV cells, so we got about 110 amp hour at 24 volts. So yeah, I can do that in my head, but I'm not going to. Whatever, we'll do it when we get back. All right, see you soon. All right, here is the router portion of the video I'm going to show you with a Hex Poe. So here's one of the perks of using a Hex Poe is that, number one, you can actually see your power consumption here by going to your interface, your Ethernet port, and going to the PoE option, and it'll show you your power consumption. Pretty cool, eh? There's your power consumption right there. You also have the ability to ping something and reboot it if it crashes, which you can put your IP address in right here, and it will ping it if it crashes. Pretty cool. So there you go. Now, so that's the first part I wanted to show you. So this Hex Poe is actually powering 2 devices, as you can see. Okay, this is handy because you want to know these numbers when you're calculating your solar power size, I guess you could say, your system size. So there's that. Okay, so now we can also monitor the battery voltage or the power voltage for the site by going to system health. And as you can see here, 23.9 volts, that's the current voltage there, and 37 Celsius, even though it is out in the cold. And I'm telling you right now, it's pretty cold outside. But yeah, so there you go. So if you wanted to monitor your battery voltage of a solar-powered site, just a small site you're using, bigger sites are a different situation, which we can cover at a later time. You can actually monitor your batteries from here. Now just remember, because this is a 24-volt system, you can take your calculator and go like this. Because most of us in here know how to use or understand 12-volt systems. So if we divide this by 2, 11.95. So I would say that's like about 60-70% capacity, like 60-70% charge currently. Which I know this thing's plugged into a wall wart, so it's fine. So there you go. There's how you monitor your voltage on your Mikrotik at your solar site remotely. And if you look here again, here's your wattage and your voltage going out to the device, so you can keep an eye on how your device is doing. There we go. And actually, what's really interesting is this one here is a prism. You can see right there, and the prism's using quite a bit more power than a rocket. We're getting up to like 7 watts here. That's pretty cool. So I'm just going to say, if you're ever working out a prism, calculate it at 10 watts just to be safe. Okay. The power beam M5s, I'd say 5 watts is good. Alright, so there you go. There's the Mikrotik portion of the video. Alright, so I guess we're at the part where I'm supposed to show you guys how a off-grid solar site works now. So I'm just using a small one as an example because, of course, if we're going to do a large one, I will take you through possible options of either a DC plant or DC to DC conversion, inversion, all that wonderful crap. So we're going with the basics here. We're going to work our way up, okay? So right here, I'm doing a site similar to the one that we just did over, or that I showed you guys earlier in the video, okay? Okay. So, what we have here, of course, your solar panels, your fuses, your MPPT charge controller, batteries, blah, blah, blah. Okay, so first of all, let's do some calculations. Yeah, I kind of... I use a slightly different site for my calculations, but whatever. Let's see here. I am no amazing teacher here. So, APs tend to draw a bit more power than CPEs or point-to-point links, depending. Because they're actually, like, they're working a little bit harder as far as CPU-wise. So, as the CPU ramps up, they're going to actually be consuming more power. So in this example, in the maths that I used here, I used a Prism 2 AC, Power Beam M5 as a backhaul, and Hex Poe as the tower router. Alright, so what we're looking at here is the Prism 2 AC draws 12 watts, so 12 watts at 24 volts is 500 milliamps, or 0.5 amps. Power Beam M5 400 equals 5 watts. 5 watts at 24 volts equals 200 milliamps, or 2 amps. I think my little arrow here. Where's my arrow? Is there such thing as an arrow on here? Huh. Yeah, I can use that. I'll use that, the select tool. Okay. Mikrotik Hex Poe, 10 watts at 24 volts, 420 milliamps, 0.5 amps. Now, if you're wondering if those maths are exactly perfect, no, they're not, because I also round up on certain things, okay? Reason for that, you always want to round up when you're doing a solar system, because if you've got a little bit of fat on the bone, it's better for you. Okay, so our total wattage consumed is 12 watt plus 5 watts plus 10 watts. That's 27 watts in total. Let me just zoom this in. There we go, fill window. Can I move that over? No. Can I move this over? No. I think I can do this. Nope. No. No, I can't. Okay, that's as big as I can go. Okay, so we've got 27 watts. That's how much power this site consumes to run, okay? Now, we need to figure out how much it uses per day. That's the next part of the equation. Right here we have 27 watts times 24 hours in a day, equals 648 watt hours per day. That is what it's consuming. Now, let's see here. We're going to go on a 5-day calculation. We can go 7 days if you want. It really depends, because you can even go 3 days. You can go 10 days. But we're going to go 5 days because it's a consistent number, and we're working with that through the rest of the calculation. Hell, you can go 1 month or 1 year. With big house systems, that we tend to go by a year because you get your averages out. And I usually weigh it based on the winter months. So, here we go. So, 648 watt hours per day times 5 days equals 3,240 watt hours per week. Alright, so now let's figure out how big the battery bank needs to be. Now, this is pretty simple math too. Now, if you want to take a screenshot of this or whatever, let me know. Or chances are you can PM me, and I can give you any worksheets or whatever, or even help you. So, here we go. Battery bank. So we want 3,240 watt hours divided by 24 volts equals 135 amp hours. Now, with some of the equipment that you're going to use, they don't specifically go to that number, you know? The numbers are going to be like in-betweens. So let's round it up to 150, because it usually goes 110, 125, 150 amp hour. There's not a lot of 135 amp hours. If you can find one, that's great. But 150 is better anyway. So 150 amp hour. That's how big of a battery bank we need to run this site for 5 days with no power coming in. Okay, that's 5 days with no power coming in. Now, onto the solar array. How big of a solar array do we need? All right. So, hold on a second here. This the view got messed up. Where's my zoom? Fill window? No. Zoom. Fit image in. That's what I wanted. Okay. So, 3240 watt hours divided by 5 hours of sunlight. I use 5 hours typically. Some installers will actually do 7 hours. If you're doing 7 hours because you're a cheap prick, okay, go 5 hours. And in fact, if you really, really want to be sticky, go 3 hours. Especially if you're up in northern areas of Ontario, which I'm talking about southern Ontario right now. So when in the wintertime, you're going to get 3 to 5 hours of decent sunlight. So what I try to do with remote systems like this, like repeater stations and whatnot, is I try to charge the entire battery bank within 1 day of good sun. So if we want to produce that much power in 5 hours of sunlight, we need a 648 solar array. Round it up to 650 watt solar array. Okay, so we know now we need 650 watts of sun coming in, or wind, or micro hydro. Whatever you've got, that will work. Again, I can discuss all this stuff later. All right, so now we know that we need 650 watts of solar to charge these batteries back up to full in 1 day. Okay, 1 good day of sunlight, which can carry your site for 5 days without any input, without any charge at all. Okay. All right, so now, how big of a solar charge controller do you need? Well, that's pretty easy. You take 650 watts and divide it by 24 volts, and you get 30 amps. So you need a 30 amp charge controller. Now, this is where I start to discuss equipment limitations. So what do we need? Well, I would say 2 12-volt 150 amp hour batteries put in series, 4 200-watt solar cells, or 2 350-watt solar cells. Now, you have to do them in pairs. There are, I should say, for this type of installation, you're going to be using the 18-volt panels, okay? Those are the standard ones for this application. So if you go, let's see here, 4 times 200 watts, that's going to be 800 watts you're going to be bringing in. You can keep the charge controller at the same current. It'll just not use it. That's the nice thing about the charge controller. It's only capable, if you choose the 30 amp, it's only capable of pulling 30 amps, processing it. So if you've got a solar array that's 800 watts, you're wasting some, okay? That's why you can also go 2 350 watt cells, which are bigger, and they take up about the same space because, I mean, like, the math showed that panels are only so efficient, right? So if you go with 2 350s, you're actually at 700 watts. So you're much closer to the 30 amp charge controller that we've got here. Doesn't really matter. It's based on money. And if you look, the current going rate in Ontario, I know, is 0.85, well, it's 85 cents per watt for a good solar panel, okay? Now, your charge controller. You definitely want to go MPPT. And in this case, I'm adding 5 amps to it. So 35 to 40 amps should be enough. Okay? 30 amps will do it perfectly fine based on the maths here. Now, discussing charge controllers. Ooh, yeah. Just a quick overview of charge controllers. I can break it down and do an entire video on them if you want. I don't recommend using PWM on a radio site. A lot of people haven't had any problems, but PWM is pulse width modulation, which means that you're going to be producing, well, RF, noise. You're going to be making noise with that thing because it's switching so bloody fast, okay? When you're using MPPT, it's got a little tiny bit of PWM circuitry in it, but typically with MPPT, it's maximum power point tracking. The charge controller is more of a DC to DC converter, and what it'll actually do is it'll allow the solar panels to run at their open circuit voltage or lightly loaded voltage. So if you take an 18-volt panel and put a blocking diode on it and put it straight onto your batteries, you're going to drop the panel voltage down to the battery voltage, which means you're going to be keeping a consistent amount of current off those cells. You're going to lose a lot of watts, okay? If you allow those panels to run at 18 volts at the rated current, you're going to be getting a lot more watts off of it, you know, overall power. Now, same thing said, depending on the charge controller, your panels can go much higher than 18 volts. Sometimes they can hit 22, 24 volts-ish. The other thing you also can consider is that in the wintertime, when it gets cold, the panels will actually work more efficiently in the cold. As they heat up, they lose efficiency, okay? So that's another perk about wintertime, is your panels are going to work more efficiently. Now, protection stuff. All right, battery bank fuse, okay? So this is the one I'm going to show you in a minute between the cells, 50 amp. Battery to charge controller, 40 amps. You want a little bit higher than the solar ones, okay? Battery bank to router, 10 amps, because that's all you're going to need for everything. See, like 0.5, 0.5, 0.2, all right? So you want about 10 amps there, and that's mainly just to keep things from getting blown up. I mean, if you really wanted to get really sticky, 0.5, so that's 1 point. You could actually say, you know what? Let's go 2.5 amps. Reason why I recommend going a little bit bigger, though, is, of course, because you never know if you're going to load something really hard, okay? So if you put a bit more of a load on it, sure, you can draw a bit more current, okay? I believe each port is capable of 1 amp, so that's 5 amps you can pull off of that router board, I believe. So that's 5 amps plus its internal, so yeah, 5 amps will be about the maximum. So rather than 10 amps, you can run 2 to 5, but I'd say just put 10 amps there. You'll be fine. We're working at such a low current that this is more or less just to protect the system from getting blown up by a short, rather than the router just drawing too much power. Chances are, if your router's drawing too much power, there's something major wrong with it and you need to replace it anyway. Okay, you're going to need a copper bus bar, lightning arresters, and number 10 cable, copper, stranded, and some number 12 solid. Alright, so there you go. Take pictures if you haven't already. Going back over here. So this is just a mock-up, okay? This is similar. This is basically a clone of the site that I visited earlier in the video. Okay, so what we have here, we got a Mikrotik Poe, Hex Poe. This is gigabit. These guys will actually push 400 banks if you really want them to, and they can. Okay, so we've got 900s at that site. So a 900 AP feeding 2 900 clients, which are way out of sight and you can't see them. Here's your mast pipe. That is literally the same mast pipe that we used on site. Batteries, fuses, charge controller, solar. Okay, so now I'm going to create a new layer here. My cat is bothering me. Okay, we're going to call this one wires. There we go. Let's draw some wires. Okay, first things first, let's do the negative system because, well, your negative is critical. It's a very, very important thing. Okay, let's just turn that down. I don't want a huge dot there. Okay, or actually, you know what? Let's do the grounding first because, you know what? Grounding is critical. And I believe when I was in electrical school, they wanted me to do grounding first, then neutral, then live. Okay, so first things first, of course, you want your mast to go to ground. You want your lightning arresters to go to ground. These guys can actually share a ground. Okay. And let's see here. You want the chassis of your charge controller to go there, and you want your solar array to go to your ground as well. The trim, the actual aluminum framing on your solar array should be grounded. Okay. This is how I did this site, folks. Okay, so now we've got that in place. Let's do the negative, okay? So if you want to see the negative here, first of all, we're going to have a negative coming from this guy, going straight down to the batteries here, okay? And then we've also got a negative going from the solar array down to here. And another one coming from here, going down to your battery terminal here. Okay, let's see, solar, charge controller. Yeah, that's cool. Okay, now let's do the hot. I'm going to do the positive. Alright, I'm going to use red. Okay, so first things first. Your solar panels, you want to go to your appropriately rated fuse. From there, you want to go into your MPPT charge controller. It's not touching it. Touch it. I'm OCD. From your charge controller into your battery bank fuse. And so on. It's pretty straightforward. Okay, and then this guy here. Let's see here. I'm drawing like a little kid. It's great. Alright, so there we go. Oh, I made a big mistake. Watch this. No. This guy actually needs to go through your fuse and then to your router. There we go. That's looking a little bit better, eh, Dolly? Now, there is another component that you can actually add in here. If you're on a hill, which you probably will be, or in an area that's prone to lightning, your mast is probably going to take a hit before your solar panels are. But you can actually get a device for this, which is called a DC lightning arrestor. Delta Systems make them. They're usually about $35. You've got a red, black, and a green. The way that those lightning arresters literally work is, I'll draw this right here. I didn't include it in this particular setup because I don't actually have one at that site, and I've never had an issue, okay? So, with a DC lightning arrestor, it's basically a bunch of metal oxide varistors. Midnight Solar makes them. They will save you a lot of money because no blown up equipment. So there's 3 wires. One goes down to Earth, and then one connects to the negative. And then you've got a red one here. Boop. That connects to your positive. And there we go. I really need to get a tablet. A tablet would be great for all this stuff. Alright, so that's the electrical system now. I didn't do breakers on the system. I kept it simple for you guys, okay? Now again, this fuse right here, this is the one that you can potentially change out if you want for a 2 to 5 amps. Let me just make that a little bit bigger. There we go. Okay, back to this. So, yep, you can make it 2 to 5 amps, or you can make it 10 amps. That's fine. Either way. Let me just save this. Yay. Okay, so now, that's the electrical system for this. Let me show you how to do the Ethernet, which is pretty damn easy. Let's do another layer. Ethernet. Okay, we're going to work in blue here, just because most people recognize Ethernet as blue wire. So for our backhaul here, simple enough. Draw, I said. Oh, that's why. Okay. So we're going to go into our lightning arrestor here. And then we're going to come out. Now, typically I go into port 2 for my backhauls. And then I start from 5 and work my way down. And then I make one a management port. Alright, so now let's do the same thing here. Alright. There we go. And then, it's just that simple. Okay, so that's your Ethernet for that. And of course, these guys go out to the homes, wherever they are, whatever. So that's basically the setup right there. That's all you need to do. It's, I don't know if there's really much more I need to tell you about that. So, yeah, that is your Ethernet. That's your DC wiring system. Take pictures if you want. I'm giving you guys crash courses and things. If you really want detailed breakdowns on things or whatnot, let me know in the comments below or whatnot. And yeah, I can definitely do huge breakdowns on specifics. Or you can just go to other YouTubers who already have made videos breaking down specific components like your charge controllers, solar panels, stuff like that. But that's it for the most part. So just an overview for you again. Here is your DC system here. This guy here, these solar panels, technically, remember I was mentioning 2 350s? This could be your 350 here, okay? Could be 350, 350, making 700, or 4 would be 200 watts apiece. And, yeah, there's also polycrystalline, microcrystalline, and amorphous cells are the most common ones. If you're in a low light area, you're going to want to go amorphous, but amorphous cells tend to be a little bit less durable. Polycrystalline, microcrystalline, they're the best way to go, typically. So, yeah, check them out. Do your research on your solar panels, because you need to do some homework. I'm just giving you the gist of how to do things. Going back over to the maths, here's your maths. Take pictures. And then this will give you your general rundown of how you can do things. I should probably make a spreadsheet somehow. I don't know how to make a spreadsheet, but whatever. You can use a spreadsheet and calculate it, or you just look at this and just replace your shit in here with what you're using, and you're good to go. All right, so that is your DC, completely DC, repeater site breakdown and overview. Yay! All right, well, again, folks, thanks for coming. Comment, subscribe, like if you want. If you've got any ideas, let me know in the comments below, and I might cover them if you need help. You can find me in the forums, and yeah, I do respond to personal messages. Alright, thanks everybody. Bye-bye.